helps binding the chlorides to the matrix, so it could be considered a sort of a corrosion inhibitor as well, or is
Well, what we are now in process is to identify this methodological phase. Actually, we do believe this is a kind of friedel salt, something intermediate where carbonate, chloride are fixing there, and not a proper corrosion inhibition itself, but the bases are pretty similar. So you are binding free chloride. So this is the point, but we need to understand how to maximize and what is the key ingredient in this methylcholine to permit exactly this. Is the finest, or is the real aluminate reactive ones, or what is exactly why a few of them are working extremely well and other are not working at the same level.
and are these bound chlorides contributing to the corrosion or in a lesser degree, or what? Are you investigating that, or?
Well, we couldn't correlate yet, but it's really chemically bonded. So we are fully convinced that these electrons are not available anymore. So it shouldn't corrode. At least gut feeling, but a bit more than gut feeling, to be honest.
Okay. And then to our Portuguese colleague, I mean, you said that the chlorides were captured by your double layer system, and also the hydroxide ions, and then you said that the hydroxide ions could be further released. Would that be the case also with the chlorides? So is there any risk of being released later on in the process?
There are two main differences. So we are talking about a clay where we introduce in the gallery the corrosion inhibitor that will be able to at the same time capture chlorides and release in parallel the corrosion inhibitor that we put inside. This is the preferential scenario. But, and that is something that we still don't know yet, there is a possibility to have some dissolution of these clays, which will be releasing some of the components from the gallery, from the structure, which is the zinc can be from that part. And if it happens, the kinetics of curing can be different. In a different way is if we have a competition between chlorides and hydroxides, and if instead of chlorides being entrapped in this gallery, and if we have hydroxides in the galleries, later the hydroxides can be released to fix chlorides. It was possible to, I don't know if I was clear or not. So during the lifetime of the additive, we have something inside, a corrosion inhibitor there that can be released to capture hydroxides, but then with time the hydroxides can be released to capture chlorides.
Okay,
but
the chlorides are more or less bound in a stable manner to this complex, or can they be released?
Yes, they are stable, except if the additives work to entrap the carbonates. After the entrapment of carbonates, the additive stops acting basically, because it's the most stable form when it captures carbonates. Okay, if it happens, it might release the chlorides that have inside.
So it's like Ramiro said with the metakaolin.
Yeah.
Similar to that.
Maybe. This too is something that we noticed, that there's some destabilization of the systems. Yeah. It depending on the weathering at early ages mainly, where it is more reactive, where the humid in the inner part is still there, so, and everything is a bit more mobile, I would say that. You really notice that we need to know more. But there is a Chinese colleague that he took more time on talking about this, and it's a bit more advanced. So now that people that are working exactly in these synergies, or as a throwback, that is a synergy contributing phenomenon with the CO2, but also the chloride at early ages. So nice to know that all the people are creating this critical mass to go further in these effects.
In fact, the difference between LDHs and kaolin, so it's two types of clays, but LDHs are anionic exchange clay and kaolin is cationic exchange. But maybe in your case you have totally solution. In our case, we hope not. Yeah,
Okay.
it's a lot of things that must be studied and really better understand.
Thank you.
Complex.
Okay, my question is for Sarah. You have talked about cracks in concrete. Well, so my question is about what do we refer about these bad cracks in concrete? I mean, we know that for a structural behavior point of view of steel reinforced concrete, we need cracks or this structure cracks, so the steel reinforcement can act as it is a reinforcement, start to work to behave like a reinforcement. So I know that from the design codes, the opening of the cracks is limited due to durability, so that we have these durability issues for the penetration, for example, of chlorides to the steel reinforcements. But for example, if we use a fiber reinforced polymers rebar instead of a steel rebar, this limit of the crack opening is not so conservative. We can have a higher opening of the cracks. So when we talk about this self-healing property of concrete in this project, Lorsenis, do we refer to the self-healing of the structural cracks, if we can say that in that way, or these cracks due to the shrinkage in the concrete?
Yes, this is a good question that I think that needs also a lot of time to answer to you, but I would like to shortly give my personal feedback. I think it's a good point of view. I mean, we can have different type of cracks in concrete. So the early cracks that are basically due to the material hydration, as the colleague introduced it in the first presentation, and then we can do something also like in internal curing, but of course we also have structural cracks. What we want to address in Lausanne is basically, I mean, for this kind of project, it's much more related to an internal curing healing, because we had a lot of work to investigate how to prevent this internal curing. From my point of view, this is one of the most important things to address, to prevent early age cracking, because the colleague after will probably discuss much more in deep with much more competences than me the topic, but I mean, I see a little bit difficult to have a self-healing at the moment with the technology add on the literature with structural cracking, because as you say, we can prevent with fiber reinforcement concrete, so we can handle the opening of the cracks, but self-healing of this kind of cracks is really challenging, and it's really difficult. But maybe one of the most important things is to prevent this kind of early aging cracks, maybe to improve the durability. It's much more easy for the public opinion when you see these very big cracks from structural loading or structural damage, but there are two different kind of mechanism, and maybe they should be handled into or different kind of solutions from the technology.
Okay, thank you very much.
Okay, sorry, we need to finish this panel, and thank you so much for your active contributing and questions. We take over the responsibility to lead the last panel to Jose Vera. So